Welcome everybody, and today I want to show you how to create your first Linux EC2 instance. Now, when you become familiar with creating your EC2 instances, it'll take you no time at all to create them. But we're going to look at every single option we have with our EC2 instances today. So it'll take us a little bit of time to create our first EC2 instance, but once you get the hang of it, you'll find that it's pretty simple to get them set up and running. You just have to do your planning ahead of time to make sure you know what to choose as you're going through it. So first and foremost, let's make sure we are choosing the region we want this EC2 instance to be set up in. So I'm going to go ahead with Canada Central from my drop-down list. And then once I've chosen Canada Central, I'm going to go under Services, and we're going to pick EC2 from our menu. And then once we are in our EC2 Management Console on the left-hand side, I'm going to click on Instances, and then we'll pick Launch Instance. So the first item on our list here, step number one, is to choose your Amazon machine image. So this is your template, and it's going to describe things like the operating system, or an operating system with applications, or an operating system with applications and different services set up on it. So you're choosing here essentially what you want running on that particular server. So under the quick start, we have our Amazon Linux AMIs, we have our SUSE Linux AMI, we have Red Hat, we have Windows in many different flavors. So depending on what you're trying to build will determine which of these AMIs you choose. Now, if you have AMIs that you've already pre-built, which we don't at this point in time, but if you did, you'd find them under My AMIs. You can also find AMIs underneath your Amazon Marketplace. You'll see here there's options for Barracuda and Juniper Networks and Trend Micro. And then there's also some community AMIs as well. And you can see that we go deeper and deeper into the options that we have when it comes to the AMIs that are available to us. So today it's just a simple Linux installation we're going to do. And I'm going to pick this top option right here, and we'll click Select. Next, step two is to choose our instance type. So instance type is referring to the amount of CPU processing power we need. How much memory do we need? How much storage space do we need? All of that comes into play here under the instance type. So you'll see that we have different families of instances. We have general purpose families. We have compute optimized. We have memory optimized, storage optimized. So depending on what you are trying to accomplish, your overall goal with this particular installation, you will choose a respective family for that. And then within those families, you have micro, you have small, you have medium, you have large, you have extra large. And that's really just the categories that AWS is using to describe the number of virtual CPUs, the amount of memory, the instance storage you're going to have, the type of network performance, whether IPv6 is supported or not. So if we go with a T2 Micro, you'll see here that we have one virtual CPU, 1 gig of RAM. But if we go for a T2 Large, we get 2 virtual CPUs, 8 gigs of RAM. And if we scroll down, we'll see some of these options with 96 virtual CPUs and 384 gigs of RAM. So planning ahead of time, strategizing, identifying what you need for your installation is going to be very important, because once you get to this page, you need to know what your requirements are. So in this example here, we're just going to pick the general purpose T2 Micro. It's good enough for this demonstration. Next, configure instance details. However, if I am happy with all the defaults, that's right, if I'm happy with all the defaults, we can just click on Review and Launch. I don't have to go through any other steps. We can launch a server right from here. But I want to go through all the other details with you, and we're going to adjust some of them and modify them to meet our needs. So let's go ahead and click on Configure Instance Details. And on this page now, we configure those instance details. So first and foremost, it's asking us how many do you want to launch? I'm just going to launch one right now, but we could launch 2, 3, 4, 5, 6, however many AWS will allow us based on our account limits. I'm going to go with 1. However, if you want to install multiple servers at the same time that are going to work together in a group, then it's highly advisable to use an auto-scaling group instead of this method right here. If you want to use spot instances, you can pick those here. More on spot instances in another video. But networking, this is where we choose which virtual network we want our server to be placed in. Right now, I don't have any virtual networks that I've created in Canada Central. So there is a default virtual network that is available called the default VPC. So I'm going to go ahead and place my server in this default VPC. However, if you have custom virtual networks already created, go ahead and choose that one if it's okay to put your server in that custom virtual network. If not, go ahead and put in this default VPC. Within a VPC, you have subnets, and there are two default subnets within our default VPC. We have a default subnet in Canada Central Availability Zone 1A, and we also have a default subnet in the Canada Central 1B Availability Zone. Or you can just say no preference and allow Amazon to choose the subnet and the availability zone simply based on however they feel like allotting it to you at this point in time. It'll typically be based on resource utilization in that particular availability zone. So if there's one availability zone being overutilized right now, they're going to go ahead and put you in the other one just to try and balance things out. So I'm going to go ahead and pick 1A. I'm not going to let AWS pick for me. I'm going to pick 1A availability zone. And then assigning the public IP address. How do I want it assigned? Do I want to just use the subnet settings? And in this case, the subnet has been configured because it says enabled here to give out IP addresses. So I could just go with that. Or I can say yes for if I click on enable. Or we can say disabled, which is really meaning no, don't give it a public IP address. So I'm just going to go with the subnet setting, which is enabled, which means give it a public IP address. IAM roles are utilized to control permissions and privileges between different resources and services and users. So for example, I can create a role that elevates my privileges so that way there I can perform some sort of action on a service that I would otherwise not have the ability to do. So if I want to perform that action, I elevate my privileges with that role and I perform that action. Well, we can do the same thing here. By default, this server is not going to have permissions to, let's say, interact with an S3 bucket. But if I create a role, like the one we see here, allow S3 to access EC2 buckets, which I created in a completely different service called Identity and Access Management. Well, I could create this role and I can now allow this server to access resources that are in an Amazon S3 bucket. Right now, we don't need that because I'm just going to go ahead and create this server and then log into it and then perform typical Linux commands on the Linux server. So I don't need a role right now. At any point in time, if you needed to add a role for the server, you can go ahead and do that. Shutdown behavior. This allows you to control what happens when somebody's in the operating system and they issue some sort of shutdown command, or they click on an option in the Windows graphical user interface and they click on shutdown to shut down the server. Well, what happens? Does the server just stop? Or is the server terminated, meaning it gets completely deleted out of your AWS account? So I'm just going to go with the default here of stop. Protect against accidental termination. This is an option that allows you to control whether somebody's allowed to terminate the server or not. So if somebody clicks on the server in the management console and they click on terminate, well then the server gets completely removed. However, if we click on this button, they would have to take an additional step. They would have to shut off accidental termination protection and then click on terminate. So it's just adding one extra step that would be required if you want to terminate the server. So this allows you just to protect yourself and your server from accidentally being terminated. I'm okay with that being unchecked right now. By default, you're going to have basic monitoring with EC2. If you want detailed monitoring at an additional cost, you click on this button and you're going to get more aggressive statistics in regards to the performance of your server. Tenancy, I'm going to go with shared here, simply meaning that when this server is launched, it's going to be on hardware that is being used by other organizations and AWS customers as well. Or I could choose dedicated, and dedicated would mean that that hardware is dedicated for me and me alone. So shared is fine right now. T2 unlimited, more on that in another session. In this case, has no effect on us whatsoever. Networking interfaces, you automatically get one primary network interface for your virtual server. If you want to add more network interfaces, you can do so by clicking on Add Device, and you'll be able to add more virtual network interface cards to that server. Advanced details, this allows you to input what is known as user data, code, scripts. And the code and scripts are going to be executed once the server is up and running. So in this case, we're launching a Linux server. When this Linux server gets launched, without any additional user data, then the server is just going to be in its default state. However, if I add user data here, once the server is completely launched, the code, the script that is in here will be executed. So for example, maybe I want to start the HTTP service. I can put code in there for that. Maybe I want the server to reach out to an S3 bucket and download files and place them in a specific folder on the server, so that way those files are available. I would put that code in there to accomplish that. So if you want your server to be more than just a basic installation, you can have code in here, scripts that will be executed, and then your server will be more readily available to you once it's up and running. So you can have it more tuned to your specific needs before you even log in by running your script right here. Next, we click on Add Storage. So I'm going to click on Add Storage. By default, you're going to get one volume, and then in this case, it's an EBS volume. It is our root volume. Default size is 8 gigs. I can increase that size to whatever I need. In this case, I can go up to 16 terabytes for an EBS volume. When you're using a root volume, the best option is the general purpose SSD GP2. But you do have other options, provisioned IOPS SSD as well as magnetic. But for root volumes, it's highly, highly recommended you go with the general purpose SSD. We're going to choose that here. Delete on termination is set right now, which means that when we delete the server, the hard drive will be deleted as well. All the information pertaining on it. If I do not want that hard drive to be deleted when we terminate the server, then I simply uncheck that, and this hard drive, this volume, it's called an EBS volume, will remain. Why? Well, when you're using an EBS volume, that is not on the same physical device as the server is. So you have your host, your server, physical server, and there are hard drives in that. Those are called ephemeral drives or instance storage volumes in the world of AWS. Well, these ones here, these EBS volumes, are more like SAN devices, storage area network devices. So the EBS volume is separated out from the actual host. So therefore, if there's a failure of the host, all your information is still available on the EBS volume. So this root volume is stored elsewhere than on the actual host. So that's why we can choose whether we want to delete on termination or whether we want to preserve that volume if the server ever gets terminated. And it's not encrypted, but we do have the ability to encrypt volumes on certain devices. If I add another volume to this server, which I can do by clicking on Add New Volume right here, you'll see that I do have the option to encrypt this one if I want to. And let's click on Add Tags. Now, tagging is a way for us to provide additional descriptions and information about our server. Most people skip this because they feel it's a waste of time. I highly encourage you to embrace tags. Tagging is going to be extremely valuable to you long term, especially when you have to provide reports on servers and services, billing information on servers and services or by department. So taking advantage of tags early on and making sure that it is something that is always done for every single AWS service you introduce is really valuable to you and your organization. So I'm just going to click on Add Tag, and here's a simple example. The key, I'm going to call it name, and then the value, well, what's the name of this server? Well, we might call it Linux SRV1 as an example. So add another tag. What department is this for? Well, let's say this particular department is hosting. What about another tag? What is the purpose right now of this server? The purpose of this server might be for just testing reasons. So the more key value pairs, the more descriptive you are with these tags and the information, the more valuable this information will be for you long-term in your organization, especially, like I said, running reports or coming up with billing information. Very, very valuable. Next, let's configure our security group. What is a security group? A security group is utilized to control the traffic that's flowing in and out of your server. You can create these security groups ahead of time, or you can create them now when you're launching a server. So if we already have one, I can click on Select an Existing Security Group. Right now in Canada Central, I only have the default security group. But let's go ahead and create a new security group here on the fly, because most of us, even though we are building the Linux server for the first time, that default security group is still not going to allow us to access the server over the internet for management purposes. So let's create a new security group right now. And I'm just going to call this one Linux Demo. Provide connection to my server. We administer our Linux servers using SSH port number 22. And AWS recognizes that, so it has already pre-populated this information for me. Whereas if it was Windows, it would populate it with RDP port numbers. So right now it's saying that you can administer or connect to this server using SSH port number 22 from any IP address in the entire world. That is not the best option. However, that's the option I'm going to go with here. So just a little advice here for each and every single one of you out there. If you're going to be connecting to this server for administrative purposes, to play around with it from your corporate network, find out what the public NAT IP addresses are that you get translated to when you go out to the internet, and populate this field with the range of addresses. If you're at home right now and you're messing around with AWS, put your router's public IP address right here, because that is typically what your internal IP address in your home is going to be translated to when you go to the internet. So change that to your public IP address of your router, so that way there you are protecting yourself from having connections from unwanted users on the internet. Whereas right now I'm allowing everybody to connect. And it even warns me here, don't do that. But hey, that's what I'm going to do in this case. Let's click on Review and Launch now. So Review and Launch. And then it's just going to go through everything. And if I'm happy with it, I'm going to click Launch. Now it asks me for a key pair. So if you have no other way to connect to your Linux server, meaning you don't have any other options in place, you haven't used the user data to script the creation of another user and to download a public key of a public-private key pair from a secure repository that you have set up so that way you can log in after the fact, you will need to create a key pair. So a key pair is a public key and a private key. The public key will be on the Linux server, and the private key will be downloaded to your personal machine you're using to create this key. So whoever creates this key will get the private key given to them. If that was somebody else in your organization, you'll have to get the private key from them in order to log into the server. Because when you log into the Linux server, it needs that private key in order to authenticate between the private and public key when you connect, as well as a username that we will find out shortly about. So I do not have a key pair right now, so I'm going to create a new key pair, and we'll call this one a Linux demo. It's that easy to create it. I click on download key pair, and it's going to download the private key to my local machine. So I have two other ones here from before, but I'm going to add this Linux demo one. Click on save, and I have it locally now in my folder. So now I'm going to click launch instance, and the instance is being launched. So let's go back now and click on view instances. And once it's ready, meaning when our instance state is running and our checks are 2 for 2, then we're going to be able to log in. So while this is going on, I need to do something in the background. Because anybody who is using Putty to connect to the Linux servers are going to need a PPK file. Well, I didn't get a PPK file. I'm going to go right now to my downloads folder, and what we're going to see here is that we have my Linux demo PEM file. Well, Putty requires a PPK. So if your terminal program, whatever you're using, is going to accept PEM files, then no problem. But if you require a PPK file, like in the case of Putty, you're going to have to convert this. So let me show you how to convert that while we're here. When you download and install Putty, you're also going to get this program here called Putty Key Generator. So open up Putty Key Generator and then click Load. Grab your PEM file. So in this case, it's Linux demo PEM. And click OK. And then click Save Private Key. And that's going to create a PPK file for you instead. Are you sure you want to save this key without a passphrase? Yes, I don't need a passphrase in this case. So click Yes. And then what do I want to call it? I'm going to call it Linux demo. And it is a PPK file, not a PEM file now. So save it as a PPK file. And there it is, showing up right there now, Linux demo. So that's the one I'm going to use now, that PPK file, when I'm using Putty. But like I said before, if your terminal program can use PEM files, then you can just use that PEM file right there. All right, so now it says running, still doing its status checks, but let's go ahead and try to log into this particular server now. I'm going to open up Putty. There it is. We need our DNS name, so we can either go with this DNS name here, or we can go with this public IP address, one or the other. So I'm going to grab the DNS name of this server, paste it in there, port number 22, using SSH. And then now under SSH, I'm going to expand that, click on auth, and this is where I put in that private key file. So I'm going to click on Browse, Linux demo, because that's the one that we told the server it's going to use. Because the server, remember, has the public key right now installed on it. This is the private key that corresponds with that public key. And then I'm just going to click Open now. And I'll get this security alert because this is a self-signed key. It's not part of the PKI system, public key infrastructure. I did this all myself. It's self-signed. It's not signed by certificate authority. So I'm happy with it, yes. And now it says, what do you want to log in as? So for everybody out there logging in for the first time to a default installation of a Linux AWS EC2 instance, it's EC2-user. And since I have the right private key and the server has the public key on it, I should successfully authenticate. So it's as easy as that, folks. I am now logged into my EC2 server. And when you pre-plan and you know exactly what you need to do, and you don't have to listen to me go through every single option, you could have the server created and you could probably get logged in within 1.5 minutes from start to finish. Fantastic. So folks, enjoy. I highly encourage you to get out there now and start creating some Linux EC2 instances. So take care, folks, and we'll see you next time.